Welcome to the Deep Dive. You're here for a close look at a recent paper that maps out the really fast-moving world of LLM-based agents and autonomous AI.
Yeah, it's evolving incredibly quickly.
So in the next few minutes, we're going to pull out the key stuff. We'll break down the newest advancements, look at a whole new taxonomy, nearly 60 benchmarks they've cataloged for testing those systems.
Rigorously testing them, yeah.
We'll also explore these emerging agent communication protocols, ACP, MCC, A2A. You'll hear what those are about.
And finally, pin down those critical open research questions. Stuff that's really top of mind for AI researchers and, ML engineers right now.
Let's get started. Okay. So this idea of LLM-based agents, let's unpack that a bit. What are we really talking about here?
Well, it's about how these large language models are moving beyond just generating text, right? They're becoming systems that can actually reason and take actions in pretty complex digital spaces.
So less like just an assistant giving you info and more like something that can figure out steps and do things to solve a problem.
Exactly. More autonomous. And the speed of innovation and the techniques behind this is, well, it's striking. The paper points out some key approaches.
Like what?
We're seeing more sophisticated ways to connect reasoning and acting. Things like React or Monte Carlo tree search. They let agents think through a problem.
Deliberate, yeah.
And then actually carry out a sequence of actions based on that thinking.
Gotcha. So it's not just the final answer, it's the how the agent figuring out the path. And the paper mentions training too, right? How we teach these things.
Definitely. Methods like learn by interact, for example, they're finding ways to synthesize good training data more efficiently.
Makes sense.
Plus, you have things like agent gen and agent tuning, which are using data from humans or even from models like GPT-4 to kind of bootstrap the training, make it richer.
And for efficiency, I know that's a big concern.
Oh, yeah. The study really highlights reinforcement learning here. Different offline algorithms, iterative refinement using rewards, feedback loops. It's all aimed at optimizing performance and, how much resource these agents use.
It feels like things are moving so fast, it's hard to keep track, which is where this paper comes in, I guess.
Exactly. It's trying to give a current, comprehensive overview, not just repeating old news.
So for our technical audience listening in, what are the paper's main contributions?
Okay, so first big one, a comparative look at almost 60 benchmarks. These were developed between, 2019 and 2025.
Wow, quite a span.
Yeah, and it gives researchers and engineers a really valuable side-by-side view of how we're actually measuring these agents' abilities.
And it's more than just a list, isn't it? They categorize them.
Right. They propose a detailed taxonomy, grouping them based on the specific skills they test. Plus, they get into agent collaboration, surveying these new protocols for agent-to-agent communication.
Crucial stuff.
And maybe most importantly, they look forward. They identify key areas for future research, the big challenges we still need to tackle.
Okay, so this deep dive is really for you, the AI researchers, the ML engineers building these systems. We want to give you a clear map of the latest evaluation tools and the big open questions.
So where should we focus? I think definitely that benchmark taxonomy first, then those agent communication protocols, ACP, MCP, A2A.
Right, and then wrap up with those future research directions highlighted in the paper.
Sounds like a plan.
All right, let's dive into these benchmarks then. Around 60 of them, you said? That's a lot.
It is, but the taxonomy helps make sense of it. It's organized around capabilities and sort of application areas.
Like?
Well, you've got general and academic knowledge reasoning. Think MMLU or that new one, Humanities Last Exam, HLE. They really probe the breadth of knowledge.
Okay, what else?
Mathematical problem solving benchmarks like Process Bench. Look at the step-by-step accuracy, how they arrive at the answer.
Important for reliability.
Definitely. And for the coders listening, there's a category for code generation and software engineering. SWE Lancer, agent as a judge.
Agent as a judge. That sounds interesting. We'll have to circle back to that one.
For sure. Then there's factual grounding and retrieval. Benchmarks like FactSand grounding. Frames, they check if the agent's answers are actually tied to reliable sources.
Especially important with RAG systems, I imagine.
Exactly. And then, domain-specific evaluations across all sorts of fields. Plus, multimodal and embodied tasks are emerging.
Multimodal, like ImageMeval.
Yeah, ImageMeval, Visual Agent Bench, pushing beyond just text. And also task orchestration managing complex workflows.
And how they interact.
Right, interactive and agentic assessments. Things like Persona Gem and Bench, which look at them in more dynamic conversational settings.
Okay, out of that huge list, are there any specific ones that really jumped out at you as particularly revealing?
Oh, definitely. ImageMeval, the 2025 one, It uses text and image puzzles from actual global competitions.
Tough stuff then.
Really tough. The state-of-the-art systems, they score around 7%. 7.
Wow.
It just highlights how far we are from human-level creative, unstructured problem solving. It's just we need, well, fundamentally new approaches maybe, beyond just scaling.
That 7% figure really puts things in perspective. What about MMLU? That one's been around a bit longer, right?
Yeah, 2021. It's been super useful for testing knowledge across loads of different subjects, like 57 of them. And it surfaced some interesting issues with model calibration.
Calibration, meaning how confident they are versus how right they are.
Exactly that. Sometimes they're very confident, but completely wrong.
Okay, another interesting one.
Complex Func Bench from 2025. This one really pushes function calling. Multi-step operations, super long inputs, up to 128K tokens.
128K tokens?
Yeah. And the paper shows big performance gaps between models here. Managing that kind of complexity is still a major hurdle.
And you mentioned humanities last exam, HLE. How does that compare?
Well, it uses expert-level academic tasks, over 100 subjects. Current LLMs, they're scoring below 10%.
Below 10% again.
It really shows the gap between pattern matching and, genuine deep academic reasoning.
What about grounding? You mentioned FACS-TTS grounding.
Right, from 2023. It checks factual accuracy and long answers, making sure it all ties back to source documents up to 32K tokens worth. And importantly, it excludes creative reasoning, purely about factual grounding.
Makes sense. And process bench for math.
Yeah, 2024. It's cool because it checks for errors within the steps of solving a math problem. Very granular look at reasoning accuracy.
How about dealing with messy, real-world data?
OmniDoc Bench 2024. That one tests understanding across 9 different document types, often with really complex layouts. Super practical.
Okay, now tell me more about agent as a judge. That sounded unique.
It is from 2024. The idea is using agent systems to evaluate other agent systems, specifically for code generation tasks.
Meta, does it work?
Apparently, yeah. High agreement with human judges, but way cheaper and faster, could be really significant for how we evaluate things going forward.
Interesting. And then there's Judge Bench, evaluating the judges.
Exactly. Also 2024. It checks how good LLM-based judges are at spotting factual and logical errors. Turns out even strong models struggle with really rigorous error detection in that role.
It's almost surprising that even simple stuff can trip them up, like simple QA.
Yeah, 2023. Short factual questions. But even advanced models show, limited accuracy and can be overconfident when they're wrong. Still basic issues there.
What else? Quickly run through a few more.
Sure. Find Tasks from 23 looks at multilingual task selection. Frames from 24 dives deep into ag-grade systems, factuality retrieval, reasoning with multi-hop questions.
Okay.
SWE Lancer from 25 uses real freelance software tasks. Turns out current LLMs still struggle with most of them.
Not quite ready to replace software engineers yet then.
Not quite. Crag 24 tests RAG on dynamic facts. OC Cult 25 is a bit scary, looks at cybersecurity risks, using LLMs for offensive cyber ops. Initial results show AI-enabled threats are advancing.
Yikes. Important area to watch.
Definitely. GIA 23 tests general assistance, reasoning, multimodality, web browsing, tool use. Big gap still between humans and AI there.
Hasselty.
Castle 24 is for software vulnerability detection. Shows limits of current methods, including LLMs, especially on bigger code bases.
And
DevStep 25 uses a step-based approach for multi-step reasoning. Low success rates highlight challenges in complex iterative thinking.
BSCL v2.
25 again, function calling, but using real user data. Shows performance really varies between models in the wild.
And finally, Tailbench.
Tailbench, yeah. 2024, evaluates conversational agents, multi-turn dialogues, using API tools. Reveals inconsistencies, even in top agents.
So looking at the overview in Table 4 in the paper, you really see this shift over time, don't you? Towards more agentic, more multimodal tests.
Absolutely. It reflects the ambition of the field, right? To build AI that can genuinely engage with the messy, complex, real world.
Okay, so we're getting better at testing these agents, but for them to really work together or with other systems they need to communicate, that brings us to protocols, right?
Exactly. As agents get more capable, standardized communication becomes, essential. This paper looks at 3 key ones popping up: ACP, MCP, and A2A.
Agent communication protocol, model context protocol, and agent-to-agent protocol. It feels like we're in a phase where different groups are proposing different standards.
That's a good way to put it. There's definitely some divergence. ACP is more focused on open source collaboration. MCP seems aimed at broad tool integration. And A2A is pushing for vendor-agnostic interoperability. It suggests, maybe a period of experimentation before things potentially converge.
Let's start with ACP then. Agent Communication Protocol. IBM Research, 2025, for their BAI platform.
That's the one. The core idea is a standard way for different open source agents and client systems to talk to each other, trying to solve that problem of everything having a different interface.
Makes sense. What are its key features?
Things like agent discovery, finding out what agents are available, delegation, handing off tasks, and multi-agent orchestration, coordinating multiple agents working together.
And they provide tools for this, the BAI server and SDKs.
Right, the infrastructure to actually use it.
Okay, next up. MCP, Model Context Protocol. Anthropic, late 2024. They called it a universal connector, like USB-C.
Yeah, that was their analogy. It's meant to be an open, flexible way for AI systems to interact with external tools and data sources.
So flexibility, but also standardization.
Kind of both. It lets agents figure out which services they need for a task and manage them. The idea is to enable more complex workflows, and they offer pre-built integrations to make it easier. Google's ADK supports it too, which is significant.
Got it. And the third one, A2A, Agent-to-Agent Protocol. Google, 2025, what's their angle?
Interoperability is the big goal here, making it seamless for AI agents to work together, even if they're on different systems, different applications, different vendors, different frameworks.
How do they aim to achieve that?
By using familiar standards, HTTP, server send events, SSE, JSON RPC, things developers already know, which should help adoption.
Smart. Any other features?
It supports real-time updates, UI negotiation between agents, and discovering capabilities via something they call agent cards.
Agent cards.
Yeah.
Interesting. The paper has a table comparing these three, right? Table 12.
Yep, very handy. Lays out their purpose, setup capabilities, typical uses, core objectives, side by side. Really clarifies the differences.
And there's a figure too, figure 13.
Yeah, it shows a potential setup using both A2A and MCP together. You see different agents built with Crew AI, LangChain, Haystack, AutoGen, collaborating and pulling in data from different places. Shows the potential for these sophisticated distributed AI systems.
Okay, so these protocols are laying the groundwork for more collaboration, but what are the big hurdles, the major research questions we still need to answer to really unlock the potential of these autonomous agents?
The paper points to several critical areas. One big one is advanced reasoning strategies.
Beyond just chain of thought.
Exactly. Chain of thought, where the model explains its steps, has been great, but the paper notes it doesn't fully model the sort of underlying cognitive process.
Right, the why behind the steps.
Yeah. So efforts like meta chain of thought or metacode are trying to capture and formalize that latent reasoning. There's work on process supervision, using synthetic data to improve reasoning, exploring new search algorithms.
So it feels like we're still just scratching the surface of truly understanding and replicating how complex reasoning works.
I think so. The paper also briefly flags failure modes in multi-agent systems and the potential for AI in automated scientific discovery have important areas needing more work.
Okay, what else? Tool integration.
Yes, dynamic tool integration using reinforcement learning. This seems really key. The paper talks about chain of tools.
Chain of tools.
Yeah, using frozen LLMs models that aren't being retrained to call tools as part of the chain of thought process. This could let them use a huge range of tools, even ones they weren't specifically trained on.
So moving away from fixed tool sets towards agents that can adaptively pick the right tool for the job.
That's the idea. But it brings huge challenges, right? Managing massive tool pools, selecting efficiently, making it interpretable, ensuring the agent makes good autonomous decisions.
Sounds complex.
It is. And the paper also introduces research. This uses RL to let agents autonomously decide when and how to use external knowledge, basically, integrating search into their thinking.
Like deciding, okay, I need to look this up now.
Precisely. But again, big hurdles remain. Scaling to lots of different tools, designing good reward functions to guide the learning, making sure it's robust and understandable, balancing exploring new tools versus using known good ones.
It really sounds like getting agents to use tools intelligently and seamlessly is a major frontier. What about security? That has to be a concern with all this interconnectedness.
Absolutely crucial. The paper specifically calls out potential security vulnerabilities in these agent protocols.
Especially the decentralized ones like MCP.
Potentially, yeah. The risks come from, say, inconsistent security practices between different implementations, maybe a lack of standard ways to authenticate agents, or even just poor logging, making it hard to debug issues.
And that could lead to
unauthorized access, data breaches. Especially in these complex workflows where multiple agents are involved, it's a serious consideration.
Definitely a reminder that security needs to be baked in from the start, not bolted on later.
Couldn't agree more.
Okay, so let's wrap up this deep dive. We've really dug into a valuable paper here, giving us a snapshot of where things stand with LLM-based agents and autonomous AI.
Yeah, we covered that comprehensive benchmark landscape.
Right, how we measure progress. And the growing importance of these standard communication protocols, ACP, MCP, A2A.
And those critical open research questions that are going to shape the next few years: advanced reasoning, dynamic tool integration, security.
It's all essential information. If you're an AI researcher or an ML engineer working in this space, it gives you that framework for understanding valuation and points towards where the biggest challenges and opportunities for innovation lie.
Absolutely. Helps focus efforts on building agents that are not just capable, but genuinely autonomous and reliable.
So here's a final thought for you to chew on. We're seeing rapid progress in LM reasoning and in how agents can collaborate. How might the interplay between these two smarter agents talking to each other more seamlessly, how might that fundamentally reshape complex AI applications in the coming years?
That's a big question. The potential for synergy there is huge.
Definitely something we're pondering as we watch this field continue to explode. Thanks for joining us on this deep dive.